Hello, welcome. I'm Eric Leblond, one of the co-founder and CTO of Stamets Networks, and I'm here with Peter Manev to present you how you can migrate from millions of events to a manageable insight using SuriCata.
Hi, my name is Peter Manev. I am Chief of Strategy and co-founder of Stamets Networks. With my colleague here, Eric, we've been also part of the SuriCon team since 2008. Looking forward to the presentation and sharing some insights of what and how we do things. Eric, back to you.
Yep. So if you can switch to the next slide. Yep. So what we're going to see today, we're going to introduce ourselves, which is already done. We're going to talk a little bit about SuriCata because I think that after 3 days of SuriCon, you know that quite a lot already. Then we will focus on how you can reduce the noise with metadata classification. Then the big problem, how you can find needle in a haystack. Then going to a demo, and then showing another approach that is really interesting, which is to switch to asset-oriented threat insight, and give you some links. Yep. So now that we so the experience that we are going to the exchange that we will going to have in this presentation is about things that we did set up for Stamets NDR, that is the flagship of Stamets Networks product. So it is based upon our experience with SuriCata, and we did take some of the principles we are using in our product and explaining how you can do this on top of SuriCata to get really value from intrusion detection and from network security monitoring using SuriCata. Yeah, so first off, there is a lot of interesting things inside SuriCata alerts. We've got the application layer metadata where you got the regular things about an alert, but you also have HTTP, TLS, SMTP information on other protocol that reach the event. So that allow you to get a bit more context about what is happening. This is a really good value when you are trying to understand or to classify the event. But something that is often not looked at is the signature metadata. So it's the metadata keyword, and it is more and more used by a rules writer to give you information about what the signature is about. And for example, here we've got the attack target, we've got the malware family, here it's global strike and the signature, what you can see here. And we also, it's new, for example, by Proofpoint, we have the meter tactic information that you can find if you want to map what the event coming out from this signature to the MITRE matrix. So, with regard to the application layer metadata inside the alert, here it's a good example. We've got an alert which is on HTTP. And as you can see, we have also the HTTP response body printable that is available. In fact, this is interesting because as a lot of HTTP requests are getting are getting back to you with compression, you don't see it in the stream. So getting the body printable, that is the decompressed content, is really the content that will be evaluated by the browser. So it's really valuable when you want to analyze the thing. Here we got also some nice information like HTTP hostname is IPv4 direct, and the HTTP port is port 443. So it gives you a lot of context on top of the alert, allowing to understand that no, it does not look like a legit request. So it adds up on top of what has been detected by the signature, because here you got IPv4 plus 443. It means that it's not something that you will find on production system usually. And with regard to metadata, there is two, one that are almost always available. It's creation and update dates. that will allow you to know that the signature corresponds to something that is recent because it has been added or that it has been updated. So that's quite useful if you want to first cover the active threat, which in a lot of cases are the recent one. By using just a filter on created hat, you manage to get this information. But this classification that we have with the signature metadata is also useful. For example, here we've got malware family, we've got targeted product. So you learn a lot about the threat that has been found by this signature. So let me introduce you to SELKS, which is a ready-to-use Debian-based distribution with ready-to-use SuriCata on the full Elastic stack, with Elasticsearch, Kibana. We did start to develop that, I think, something like 5 or 6 years ago now. It has been ready to use Debian-based distribution, but now it's not only Debian-based, it's also Docker-based. So you can have a Docker version that you can install super fast to get up and running a SuriCata with a web management interface on the full stack, full Elasticsearch stack with Logstash and Kibana. So it's freely available, the code is public, and you can contribute if you want on GitHub or ask questions on Get Download. So what is the challenge that we are going to try to cover here in the rest of the presentation? So in the typical enterprise, you can have something like 10 million of alerts per day and 500 million of network events, maybe more. So this is really a problem about getting a lot of data and trying to focus on what does really matter to you, what are really the threats on the network. Detection is not about getting a Christmas tree, it's about getting an alarm. So you need to focus on what does really matter. And then after, maybe you can, if you have time, focus on things, try to find some strange stuff. But first, you need to find the obvious, and you need to have an efficient way to do it and an efficient way to lower the noise. So something that you can do is, even with this alert where you have 10 million of alerts a day, you need to filter them out. If you just suppress them, you will lose context. So it's not a good way to just filter out. So it's better to add filter on top so you can focus on some aspect of the signature and then see. But what kind of filter should you use? One thing that you should not use is severity, because the rules writer in a lot of cases don't set it correctly, and then it gets the default value, which is critical. So severity 1 is by default, it can be something where the rule writer did forget to put the severity. So something that is better to do is to use the metadata classification, where you got more information and you can have a way to focus, for example, on CNC, on malware, because it's part of the classification. And another way, and complementary way to do it, is the hunting approach, where you look at alert and you combine this with some other factor, like a suspect or an unusual content. It could be a strange HTTP user agent. It can be an old TLS version that is not used anymore in production. So all those things allow you to find combination based on alert to escalate some alert from it's kind of a noise to that is maybe interesting to look at. So I now end up it to Peter. He will present you what you can do with SELKS on Serious Community Edition.
So folks, what you see in front of you is actually the landing page of the Serious Community Edition, or SELKS rather. Just to follow up with some hands-on examples of some of the hints that Eric was giving previously on. So from here, I'm going to jump over to our threat hunting interface, the Serious Community Edition. What we have here loaded up is an example data from malware traffic analysis, so real malware. And what we see here is basically just a small sample out of it. So often enough, when I look at the screen, and I like hunting a lot myself, what we have here is actually pretty powerful, and I'd like to show you how and why, and at least one or a couple rather of examples of that you can take home and apply it in your production environment, for example. So we have here the dashboard, which is basically what we aimed here is the threat hunting dashboard to create all the metadata that's kind of available from the Suricata alerts and create a powerful hunting dashboard where we can actually zoom in on any specific fields, be it like the metadata of the signature or the malware family or user agents or host names, whatever data is available in those loads, it will be actually displayed here and all broken down. So you can actually easily click on and select in and zoom on things. Now, what I mean by that? Well, in some ways, it's pretty easy to zoom in and, for example, zoom in on by category. And one of the categories that's in the signature is malware command and control activity detected. So it's pretty easy to zoom in right away on stuff like that. And in live production, that helps a lot because that brings actually down the alerts from millions to a few that you can actually need to review. In this case, of course, we're lucky because here actually we have a PCAP that's loaded against the proof point open rule set. So only that. So we don't even have the pro, which has much more context and much more coverage. I mean, we have not even loaded here yet like any other available rule sets, like freely available. So like abuse, CH, and similar. So in this case, we're lucky because here right away we can see, okay, there's a strict book involved in there. And that's the easy part. You know, that's where the rule writers from places like Proofpoint, Abuse, CH, and similar other organizations that provide rules make it kind of easier. But I'm always wondering, what if there's no coverage for that specific, let's say, threat, or you might come in, the coverage might come in a bit later. And one thing that actually always yield interesting results, at least in the wild, in our testing, is as I was reviewing this specific sample and actually comparing that to production data, where you actually have a lot more alerts, not just 40 or 50, let's say, so it's quite a different angle. As I was browsing through, first we came up with the concept of actually guided hunting, or like using predefined filter sets based on metadata. What I mean by that? By that I mean the following. If you look at all these signatures here, mostly you see the majority is policy or info alerts. And those signatures are usually one of the first ones that come in and get switched off or suppressed or thresholded because they create a lot of noise. And usually the principle is like you would have, okay, there is this executable signature, or this executable signature, or just a one showing plain simple executable download, like this one in here. You'll be like, okay, that's false positive. So what does false positive mean? Usually the approach that we see, at least most of the cases, is something saying that, let me try to figure out if this signature is true positive or false positive. This has a disadvantage because you're actually only reviewing it one signature at a time. So how about we use all the metadata that Suricata provides us, and we actually zoom in on a more interesting case where we can actually have a few of these signatures clicking in together. What I mean by that, that's why we have some predefined filter sets where you can actually zoom on different aspects of the metadata. So for example, you can zoom in, click directly on malware, and that will use specific tags, or for example, you can actually hunt for all the versions and have a predefined filter sets and be like, okay, this is an alert with TLS protocol metadata that is using an older version of TLS, let's say. That gives a different aspect. It's not per signature per se. One interesting one that I found most of the time is actually this one. So basically, it's an Elasticsearch query that kind of returns something really simple. It says, give me all HTTP related alerts that are actually pulse or gets or whichever to a public IPv4 address. And as I was reviewing with that filter set, this specific example, there's a few things that pop up, but I was trying to create something a bit more generic. So, okay, the user agent ghost is kind of unusual, but curl, actually, it is present a lot in production and similar things. So I actually wanted to zoom in on that. And then I actually wanted to say, okay, give me also all the status 200 actually did happen. And that's what I ended up with. So at this point, this will actually zoom out only on user agents curl specific with that version with status code 200. I wanted to make this a bit more generic, so I was actually going to go ahead and wildcard the curl, so it can actually be any curl user agent, for example, and click Save. I don't need the HTTP anymore. So now I have a filter that actually can use and that is not dependent on a specific signature, okay? So this returns me a user agent curl downloads a executable from a public IP address. So what is interesting about these signatures that they actually, this specific filter returns them together. And if I go over and look at the example, I can pretty easily open one. And let's say, again, there's plenty of metadata in here in terms of HTTP flow information, including when was the signature created, updated, and so on. But we also have the payload printable, as Eric was mentioning, the response body as more evidence. We also have all the rest of the related information, as this is part of the same flow. So here we have the file transaction itself containing the checksums, we have the flow records itself, and we have the HTTP requests, request and response headers, the HTTP log itself, and also all the rest of the alerts that were part of the same communication, the same flow. Here is the trick, actually. So if I go in and actually we have a field that's called flow ID, this actually makes sure all transactions or protocol data related to a specific flow stick together, actually. So if I zoom in on that flow, funny enough, it just gives me the exact same for alerts, right? So basically, this is because they're part of the same flow, and that's one of the tricks. So if I actually I use that as a confirmation. So if actually I can use that filter as a pretty generic way of kind of finding interesting stuff out. And the other advantage of this approach, of course, is that actually it does not depend on a specific pattern inside for a specific threat actor, okay? This is basically a very generic way of saying we have an executable with a curl user agent from a public IPv4 address, and it generates all these alerts in a bundle. That is a bit more generic way of actually raising your attention up to things that could be much more interesting for threat hunt, rather than trying to prove if a single signature is a true or false positive. Again, this is just one way of doing it, that the user agents could be different and so on and so forth, but you can always actually save that filter and then continue on creating more as you're going through the hunt. And that's what I've done here. I have that filter saved in here, so I can go in and use it as a hunt or as a starting point for a hunt anytime I would like to do that based on alert and metadata and protocol data from SuriCata. And that's basically the one of the principles, or one of the ways that we can do threat hunting with metadata in with SuriCata alerts. So, folks, that was a quick demonstration on actually looking at the malware pickup from traffic analysis at SELKS. You can definitely try that at home on any Linux OS or a Docker system. that you have Docker on. Inside 2 minutes guaranteed, as you can see on the screenshot. It's very easy to spin up and basically dive in yourself. Really easy stuff. Now, when we focus on metadata filter sets, there is a few ways you can approach the hand. There is different ways. I've demoed some of these on the live demo. These are screenshots to give you a few more ideas of how we can approach it. And as you can notice, one of the main points here is to not concentrate on a specific signature, but concentrate on the metadata that it produces. So in this case, we are actually, okay, we're looking for malware. Then we can actually look on a category, in this case, malware command control. We can also have some funky stuff in here, really like basically executable signatures that are firing up on HTTP content that advertises itself as an image, let's say. Some kind of pretty interesting results come in, and they're also available in the filter sets in the predefined filter set in Sirius, and also used by actors like TrickBot, Dridex, Eurosniff. Another thing you can do is a bit of a long query, but basically these are direct IPv4.quad connections, not using like a domain name, just IP address. Another idea would be to actually look for a bit of an older, let's say, protocols or TLS versions, let's say, unsupported TLS protocol usage in this example. Also, another idea could be, hey, you can search for the keyword root inside the alert events, inside the payload printable. And in this case, we're looking at HTTP alerts only. Well, I mean, filtering is great. It provides an awesome way of actually diving in, but it still has its challenges, right? So it's not, it doesn't end there. Okay, so there is a start, there is a good starting point, there is a way of doing things. We need a global view of what's relevant, okay, because you have your meetings every day, you have your calls, and then you only have so much time to actually do things, hands-on, for example. So iterating on the same job actually becomes a bit painful. So one solution, one approach would be to classify tag for priority, right? So escalate certain group of events or events for prioritization. A couple of implementation possibilities are, you can run a set of queries towards Elasticsearch or Splunk or whichever you use to update the data. You can also add post-processing on JSON data produced by SuriCata. To add a bit more of a tagging or priority, if you will. Simple but useful two-option classification is to just be a little bit of, this is info, this is kind of relevant for that. And actually, to kick it up to the next level, I'll transfer it over to my colleague and friend Eric here.
So the next thing that is interesting is that in a lot of cases, you are just looking at event. What you really want to do, in fact, is prepare for incident response or provide things that are ready for incident response. If you're an analyst, you want to know what threats are on your asset. You don't really care that there is an event. You really want to know that there is a threat on an asset, but this threat is active. So for example, if you take alert on a CNC beacon, what does really matter is that between this point in time and up till now, or maybe a little bit before, you have seen a CNC beacon on one asset. So that's something that you can do, but there is some complication due to the fact the way signatures are written. But if you manage to do it, then in this case, you can do things like list of asset under threads. You can limit the point. You go straight to the point, finding a threat in your environment on your asset. But you need some methodology to do it. And first one is, how do I identify the who? Which means Is it the destination IP that is the asset? Is this the source IP that is the asset? You need to know, because if you want to list all the source IP that have threat, maybe you will list the attacker in this, so that will not be correct. So if you look at these two signatures, you will see that is not that obvious. If you take the first one, but go from external net to home net, and we have pattern matching on something that is going through your home net. So in fact, the source is the one triggering the attack on the home net, which is the target. So the asset will be the destination IP. But if you take the other one, in this case, we've got response 403, which corresponds to an error, and it's too fast, so it may be a scanning. So in fact, in this case, we will look at the response coming from the IP to determine what side is the one that is attacked. So in fact, here the source IP is the target. In the first one, the dest IP is the target. So you cannot say that dest IP or source IP is the asset. So you need to find something else. So what you can do is use something that I did introduce in 2016, something like 5 years ago, which is the target keyword that allow you to point to the asset side. So if you manage this, it's quite simple. Take the signature here, for example, we've got ET malware global strike, and we have Omnet on the left, and we are looking at some content, which is the get, which proves that the source IP is doing a request that prove that it is compromised. So in this case, target is the source IP. You can add this keyword on the signature. And then if you do this, what will happen is that you will have new fields and new sub-object in the alert object inside the JSON. So for example, here we got alert source and alert target, and both contain the IP on the port. So you know which one is the source and which one is the target. So too badly, this has not been used by the most of the rule writer, and as a result, this is what we are doing in SELKS. We have an algorithm to automatically determine which one is the good size, and we managed to get some correct result on this, but it will be really better if ever the rule writer were in fact using this. So please, can I have target in the signature you wrote? It would be really useful. So by doing this, in fact, you manage to do exactly what we did discuss before. If you have a target, and if you are using the signature metadata malware family, you can just build this simple visualization in Kibana, which is alert target IP and second bucket, alert metadata malware family. And by doing this, you have the list of assets with the list of threats that has been seen on this asset. So this is really simple, really powerful. It just depends on the target and on the classification metadata that has been set on the alert. So this is something that we have industrialized in Stamus network detection and response product, where we're using this principle on some more stateful logic. We managed to do a timeline of event showing you how the threat did evolve over time on one host, mapping that on the kill chain. So you see really what is going on every asset that are under attack, and see the method that have been used by the attacker. So I will let Peter finish, because he's also responsible of the threat intel at Stamus Networks.
Thank you, Eric. So, well, just to add a couple of small things. So, signature classification can be complex. First of all, there's not just one source. There could be many sources. There could be different as thousand ways of writing rules, requires the signature writers to actually add in a few more keywords in there that could help. A signature by itself or a rule by itself is not necessarily always an indicator that something is bad. It could be just context. I personally look at those just as a signature, any signature as just context. Begin with context. Of course, some signatures based on known bad IOCs, yeah, okay, absolutely, but it's not the case with majority. So it's always context that is usable. So that doesn't make it really any more easier to classify and to be sure to escalate events. And then, of course, as I mentioned initially, a variety of sources. So basically what is required is a cycle. Like you need to review the intel, you need to glue it together, you need to see what's useful, how to use it for your specific ecosystem, for the specific areas that you defend or organizations. Update the signatures and push the intelligence feed updated. And here we're just talking about signature. There's other stuff. There's the protocol data that SuriCon produces that you can do analysis there too. And there's just regular either IOC that list that could be loaded as well, and so on and so forth. But just as a few points to consider. So, Eric, shall I throw it back to you for conclusion, sir?
Yeah, sure, no problem. So you can really build a really efficient detection on top of Suricata. All the capabilities of Suricata allow you to get excellent data, but the data are also dependent for the signature part on the quality of the signature. But if you work regularly on your alert stream, you can tag, filter things, and then you manage to get the noise out without losing the context. It's really important not to lose the context. And as much as you can, you should use the asset-oriented insight that will give you really an easy entry point without just because you are just showing what assets are under attack in your network. So a few pointers to the resources. Feel free to try SELKS. It's really easy to use now with the Docker installation. It's just a few minutes, as mentioned by Peter before. Thanks.
Thank you very much, folks. Thank you very much, Eric, and the OISF and the SuriCon team. Much appreciated to be here.